This is lesson 54 on multiplication. Here is the truth table for a binary multiplication. Notice that the inputs can either be 0 or 1. 0 times 0 is 0, 0 times 1 is 0, 1 times 0 is 0, 1 times 1 is 1. So to multiply 2 bits, you just need an AND gate. Let's use this to try to multiply 13 times 12 in binary. If we did it in decimal, we see that the answer is 156. So 13 is 1101. 12 is 1100. So you do binary multiplication just like you did decimal. You multiply each bit and then you shift the partial products over and add them. So 0 times 1 is 0. 0 times anything is 0, so this will all be zeros. This is 0 times that is 0. We shift it over. Now we have 1 times 1 is 1. 1 times anything is anything. So we get 1101 brought down, shifted over again 1 bit. And finally 1101 we shift over again. And if we add these, we get 9C, which is 156 decimal. So binary multiplication works the same way as long multiplication. Now, we could think of these as hex numbers. If you multiply in hex, the multiplication table becomes a little more complicated. Here we have 16 values, 0 to F and 0 to F, and this is the hex multiplication table. You can see that this is more complicated than the decimal one. It's probably a good thing you didn't have 8 fingers on each hand. You'd have to learn this hex multiplication table when you were in school rather than the decimal one. But let's see how it works. Suppose we want to multiply the decimal 61 by 90. The answer is 5490. Well, 61 in hex is 3D, and 90 in hex is 5A. Well, you do it the same way. You need A times D. Well, you look here, you have A times D. You see it's 82. So you put down the 2 and carry the 8. So A times D is 82. You put down the 2, you carry the 8. Then A times 3 is 1E from here. There's 1E plus the 8 that you carried. 1E plus 8 is 26. We put 26. So this is the partial product of A times 3D. And then you do 5D, shift it over 1 digit. So 5 times D, you look up here, 5 times D. And you see 5 times D is 41. So you put down the 1, carry the 4. 5 times 3 is 15, or F, plus 4 is 19, or 1, 3. Put down the 1, 3. And now you add 2, 7, 5, 1. And so 1572 base 16 would be 3D times 5A, and that's the equivalent of 5490. Okay, we want to see if we can figure out how to make a circuit to do binary multiplication. So let's take a look at this one. Let's take 13 times 11. The answer is going to be 143 decimal, or 8F hex. Well, 13 is 1101, and then the multiplier will be 11, or 1011. So in binary, what do? We take 1 times 1. Well, that's just 1 times anything, so that's going to have 1101. And then here we'll take 1 times 1101, shift it over 1 bit. But now we'll add it to get a partial product here. So we're going to add each bit as we go along. So this is going to be 100111. Now we have the 0. Well, the 0 is just going to be 0 shifted over. So we add it, we get this. Finally, we're going to have 1 times 1101, and that'll be shifted over again. And we do the final addition, and we get 8F, which is the correct answer. Now, how can we turn this into hardware? Well, this circuit will do it. What we're going to do is we'll take the 1101, this is the multiplicand, we're going to add 4 leading zeros and call it BP, so this will be an 8-bit number. So this is B here. And then we're going to start with an 8-bit product setting equal to 0. That's going to end up being the product. And then the multiplier 1, 0, 1, 1 is going to be A. So this is going to be 1, 0, 1, 1. Those are going to be the inputs to these multiplexers. This is the control line to the multiplexer. So we have 4 copies of the same circuit, an adder, multiplexer, and a shift left. And this is just going to implement this long multiplication. So let's see what happens. The first A0 is this 1. Well, if it's 1, then the sum, which is going to be the sum of these, will get through the multiplexer. So the 1, 1, 0, 1, of course it'll have 3 leading zeros here, it's going to be an 8-bit number coming through here. That will be sitting here at the output of the multiplexer. Of course, the B, which is a 1, 1, 0, 1, is going to get shifted left. So it's going to get shifted left just like we want for the long multiplication. So that will be sitting here. And now we look at A1. Well, A1 is also 1. So this multiplexer will take the sum and let the sum through. Well, this sum is going to be 1, 0, 0, 1, 1, 1. That's what's going to show up here now. And of course, this 1, 1, 0, 1 gets shifted left again. Of course, I'm going to write it as zeros here because this bit is 0. Well, if this bit is 0, so that's A2, that means that this sum, partial sum here, which is sitting here, is just going to get through to here. It's not going to go through the adder. And sitting here will be this bit shifted over. But now it's going to get shifted again with this shifter. So this sum is going to be sitting right here. And then this shifted again will be sitting here. So this bit shifted is going to be sitting here. This 1, 1, 0, 1. And here will be the sum. Well, now A3 is a 1 here, so it's going to let the sum through. And so this sum will show up as the product, and in fact that's the product, 9F, 8F. So you see this circuit works to do a binary multiplication of 4 bits. Each bit of the multiplier ends up being the control line for this multiplexer. Okay, well that works for unsigned multiplication. Let me just say a bit about how signed multiplication differs. Ends up there are 2 cases. Here we show minus 3 times 7 is minus 21. If this multiplier is positive, then it works this way. It's almost the same as we had before. We multiply this 1 times this. The only difference is we need to sign extend each partial product. So if this is a negative number, minus 3 you see here, then we have to sign extend it, that is fill all these with 1s if it's a 1. If it's a 0, you'd extend it with zeros. So then we shift over this bit again, has to be sign extended. We add these, sign extend, you have a 1 here, sign extend, and then you add it. This is going to be 0, so we don't have to do any more. And when you get done, this will be negative 21. You can see if you take the 2's complement of this, you get 21. So this is negative 21. So you get the correct answer if you just sign extend all the partial products. Now that works if this multiplier is positive. However, if the multiplier is negative, so they're both negative now, well, minus 3 times minus 5 is plus 15. It works almost the same way, except you have to do one extra step. Here you multiply 1, they get sign extended, 1, sign extended. You add these, you get a 0. And then this last multiplier here, instead of multiplying by 1, adding 1, 1, 0, 1, that is the shifted value, you need to take the 2's complement of the 1, 1, 0, 1, that is the minus 3, so it turns out to plus 3. So in the last step, you don't take the sign extended of minus 3, you take the 2's complement, so it's plus 3. Now if you add that, you'll end up with plus 15, which is the correct answer.